cover risk management for about 40 minutes today. I said about 30, but we're going to cover the topics. This is the number 1 and 2 topics for the ASP, CSP, and CHST. With the CSP, you will have at least 25 questions in this area. Not everything is all about risk, but you'll see a couple of these other questions that I put in knowledge checks, but quite a lot of material to cover, and I'm just going to tip the iceberg of the most common ones, and we go through it. And with risk management, it's going to be an outcome I put down. It's in the ASP domain 2 and CSP domain 3. It's also in the CHST. CHST, you're probably only going to get about 7 to 10 questions related to it. I don't use any of the actual test questions. I rewrite the test questions that I know of. You know, I've been doing this for 20 years, so I have people give me feedback what they see, and you know, if a question doesn't appear in 10 years, I usually drop it out of the bank. Again, with terms, they're going to always ask you about risk management or risk control. That's almost a guaranteed question. You know, you have to know the difference of them. The issue is that risk management is the supervision of the risk. They are people who are risk managers who do this for large corporations, and they go through and they know the insurance side very well. 12, 15 years ago, maybe not a lot of questions, but every October they rewrite the questions, and they go through and add new questions, and obviously the risk people have had a lot of input in the last 5 years. And again, risk control is a subset of it. It's just talking about how to get rid of the risk or how to minimize the risk. And then there's terms you're going to have to know, and these are terms that are not used in the safety profession too often. Again, I always call them more insurance terms. Pure risk means we have a chance of a loss or no loss, but we won't make money on it. That means if you have, you know, in Florida, you have alligators on your property, that's a risk. And if you don't deal with the risk, you don't want some little kid coming up there and, you know, feeding the alligators. Speculative risk means you're not going to have a loss or a gain, but it's a chance. So that means you could, you know, have a risk where you have something you're speculating on, like a stock or an option to protect the futures of wheat or oil or anything else like that. And then the loss exposures, there's different types, and you can see anytime you get the, you know, a list of loss exposures, a common test question is to list 3 and put 1 that's not in there, or list 1 that's correct and put 3 that are not loss exposures. But property loss, everybody understands. We have a chemical plant like this and it blows up. We have a lot of property loss, $1 billion in some of these cases. Liability is the loss from a damage claim. I do a lot of expert witness work, so I deal with liability for, you know, what they call negligence for a multi-employer. Personal loss means we got people that have, you know, got hurt or killed, and if you have somebody with 10, 15 years, 20 years of experience, you cannot replace that person very easily. And then, of course, any kind of loss could result in a net income loss where the company is not going to make any money. And the hazards are different. This is a, you know, again, the risk side of the question. We don't see this too much in safety, but the moral hazard is we have people who are dishonest. You know, we have people who steal money. They go out and make up false business reports. You know, Enron is a good example of a moral loss where they asked dishonestly, inflated the value, inflated the revenues, and none of that was true. Morale loss means we don't care to deal with anything. When OSHA is dealing with us right now, they're having problems with the what we call the dollar stores, where they have no care to seem to try to prevent blocking the exits. So a company was just cited this week, $1 million for blocking exits. Again, that would be a morale loss, you know, where if there was indeed a loss related to it. And again, physical hazards means we're going to lose some part of our property or even the people in the operations. And legal hazards means you have a issue of liability related to legal. And you know, the largest awards could be in there from person getting hurt or people getting sick from your product. So we'll go through a knowledge check. These are, you know, like I said, I just rewrite the questions. Which pure risk situation is covered by the worker compensation insurance? So you can go into the chat and just type in what you think it is. You know, if you can just guess what you think it is. And I'll go for at least, we got 9, we go into about like 4 or 5 people answer this one. Risk of lightning strike, risk of building value dropping, risk of vehicle damage in a car accident, risk of amputating machine finger in a machine. What do you think pure risk? And this is a hard question, but these are the risk management side. They are not easy. So the answer is risk of amputating a finger is a pure risk. We have a chance of a loss, but we're not going to make money on this amputation. Risk management, there's a lot of different schools about the process of it, but generally it's a 6 or 7 step process. What you may have is they may ask you the steps, and they'll put them in different orders. You know, they'll give you 4 of these hazards or 4 of these steps, and then they tell you which is the process. And you identify the hazard. We got to go up and change the light bulb up here. We assess the hazard. We got a problem here easily of, you know, the workers now working on the ladder with 2 hands. If you read the ladder stickers on every ladder now, it says you must face the ladder and have a firm grip on it. So if you're taking your fingers and your hands off to work two-handed, you're in violation of the manufacturer's rules, which OSHA would say you're using the ladder as not intended. Most people do not know about it because they haven't read the rules in 10 years. But this is be a violation. You're not allowed to work on a step ladder two-handed anymore. And then the feasibility controls, we can get a portable lift. We can make a decision. A lot of contractors say, you know, you're not going to bring a ladder on the job sites. You're not going to bring a ladder in the area. We'll get a portable scissor lift or a aerial lift or some other device to get you up there. And you implement the controls. You make sure you supervise and you audit it, because otherwise some people will not do the way because they don't like change. Risk control is a subset of risk management. Has a goal of 0 injuries and illnesses, reduce costs, prioritize costs in risk decision-making process, minimizes the risk through safety interventions and insurance. So type in chat, you know, what you think it is. And the trouble is, these are all kind of close, so they have a best answer. One of the things you'll see is that even though I talked about it, you're going to have to probably review it one more time, because a lot of these concepts, it's like me speaking a language that you don't understand. You can remember I said it, but you can't recall it very easily. It takes usually 3 times before you can remember these things. The answer is going to be, it's a subset of risk management. And they'll give you sometimes what is loss control. That means you're trying to control the losses. Again, hazard identification awareness is going to be, you know, we're going to think about these hazards. Like we said, okay, we got to get up there, we got to change it. You got to think about what you're going to do to eliminate or minimize these hazards, and what could go wrong, what's the consequences, and then how often could it happen. You can actually quantify these things. So a common one that I see a lot is the risk matrix. It's going to talk about how do you calculate the frequency probability of it. Some people said, well, what's the chance of you getting hurt? Well, we know ladders are the #1 cause of death in workplace for falls. So you can say that, you know, hazard is going to be fairly frequent. And if you fall from a ladder, you know, it could be a death. It could be a catastrophe. So you could say two-handed work on a ladder is a high, frequent, possibly catastrophic case. And you can say, well, I've done training. I'm going to minimize, you know, the likelihood to maybe occasional. But you're going to have to go through it. The question is, if you have a lot of hazards, like in some of these audits I've been at the food companies, I have anywhere from 23 to 32 hazards. So they always ask, which one do I fix first? And we can kind of use this to prioritize which ones we know are going to be a problem. We know lockout in the food industry is a real problem, and OSHA is going after that issue quite a bit. So we're going to say anything with lockout, you got to do it every day to clean machinery. It is a lot, probably the #1 killer in the food industry. So we're going to say that's high priority, versus you might have oxygen and acetylene stored together. It's a low probability of occurrence or remote, let's say. You got ventilation, it's probably not going to cause any injury, you know. So you can prioritize it. Obviously, anything in the red you got to deal with. And the knowledge check, risk matrix is based on two general elements. What did we cover? The person's injury index and affected cost of medical treatment, the probability of occurrence and severity of outcome, the skill of the worker and the work environment, the frequency of task and number of workers involved. What do you think? Just type in chat. Okay, everybody got that one. Probability and the severity of the outcome. Very good. Risk transfer is a common one you're going to get on the construction side. The reason you don't, as a company, hire your contractors directly is that you're going to have the risk of any issues that come up that they could get hurt or damaged. So many companies will hire a general contractor and transfer the risk to them. They supervise the project. They have the talent to know who's good, who's not. They know how to budget the job site, and they can get a good idea how much it costs. So again, it's a common way to ship the risk to a different entity and eliminate it from you. And of course, they will have to have insurance in case there is an accident or a fire or something else like that. So risk transfer is a method of resolving direct or indirect costs process which is ideally suited for use with the risk matrix, a technique which shifts the financial risk from one party to another, safety principles involving worker rotation. What do you think? Put in the chat. Okay, very good. Techniques which shifts the financial risk from one party to another. Again, one of the things you'll hear is return on investment, and it's a controversial topic in safety. But the idea is that we're not going to do training to document our investments. There's things you have to do. But if you're going to go out and put a lifting device for $20,000 to help lift a barrel onto a pallet, then you can justify what you've cost for a year. You may have a lot of people doing this and getting $1 million worth of injuries. The cost in putting in several of these devices could be $250,000, and we would sit there and figure out, wow, our payback's going to be fairly fast. You know, if it only costs $250,000, about 1/4 of the year we're going to pay back the cost. So they call this return on investment calculations. You may get one. They'll tell you, here's the cost that we've had in injuries, here's the cost of the control, and then how many months would it take to pay back? Or what's a return on investment? The return on investment calculations are useful calculating a budget, showing the financial risk, determining whether to use PPE or engineering controls, determining the profitability of an expenditure. Type that in chat. And it's going to be determining the profitability of the expenditure. We're going to spend money. How long would it take to pay back? Because if you spend something that costs $1 million and you don't have but maybe $10,000 of injuries, that's a long payback for something that's out there, you know. So you have to look at it. If it's required by the law, that's a different animal. But if you're doing something to eliminate these injuries, you got to look at this issue. You're always going to get in the CSP the Pareto principle. You know, I hear about it, 80% of the sales come from 20% of the people, or, you know, the injuries that you have are 20% of the causes, you know, and it's a rule that works until it doesn't. There's plenty of exceptions to this rule, but they always talk about, you know, 80% of the dollars in your claims are going to be 20% of the sources. Not everything is going to be equal for injuries and illnesses. Then risk management sometimes gets in the process safety management. That's kind of a spot where they put it in there. There were some several accidents. You know, Bhopal killed over 5,000 people in India with methyl isocyanate. Several 100,000 got crippled, blind, kidney cancer, liver cancers, and all these other ones. The similar incident with Union Carbide also in Bhopal. Released it, but it went down the river and killed more animals. Didn't really kill any people. And that started the process safety management. So OSHA had requirement under the Clean Air Act, under Secretary Labor Elizabeth Dole, to develop a process safety management. Because I was doing this before there was an OSHA rule, everything was what they call under the General Duty Clause. So it has 13 elements, as I call it. The trade secret's the 14th element, but the idea is that they're going to have to go in a company that has 10,000 pounds of flammables or ammonia or 5,000 pounds of chlorine or some other chemicals that are hazardous and develop all these procedures to prevent an unexpected catastrophic release. And that's what they're going to go through. So some of these were part of OSHA standards like hot works and training, but a lot of these mechanical integrity for pumps, compressors, valves, instrumentation were not. In the in the process hazard standard, you have to do a process hazard analysis. That means you're going to sit there and do a detailed analysis to see what could cause a deviation in the process and what would the consequence be. And you may sit there and take something that's simple like a pressure vessel. What would cause it to overpressurize? And you develop scenarios related to that. And then what would your controls be? Well, we're going to add relief valves. We're going to have the ability to dump the contents out of the vessel right away to a flare. We're going to have monitors that monitor the pressure, the liquid level, everything else. So these are complex studies that are done at the chemical industry. Refrigeration warehouses have over 10,000 pounds of ammonia. Power plants have over 10,000 pounds of ammonia. They have to do a similar analysis too. So the Process Safety Management Program closely parallels FEMA's risk management program, applies to all chemical processes, begins with a process hazard analysis, and requires submitting hazard determinations to the State Environmental Board. This is a tougher question. Type in chat. It's going to begin with a process hazard analysis. It does parallel the EPA's risk management program, but not FEMA's. And again, the process hazard analysis, you're going to have all the instrumentation diagrams. You have to know the process. And you know, when we were looking at the 80s, nobody had this. Some companies like Mobil Oil and you know, some of the big chemical companies like BP and everyone else, they had these, but a lot of these were not up to date. This standard requires it to be reviewed. You're going to go over and have a data sheet for all your chemicals. You're going to have to know the codes. Holy smokes, when I started this with OSHA, there were over 35 codes just for chemical processes. There was a code on pumps, there was a code on compressors, code on piping, code for instrumentation. It was literally thousands of dollars of codes. And you know, we didn't have the internet back then, so we had to go through these codes and see what we were doing. And that's what we did under the General Duty Clause too. You got to have a planned operating procedure. You have to have shutdown procedures. When do you plan to shut down? What conditions would trigger an emergency shutdown? So these are all things that people would have to ask. And they want the team involved with people who are out there in the field, as well as other people that are involved and knowledgeable about the process. The Hazop is a common one used in there. It's you know, you're not restricted to it, but I see a lot of it. It uses guide words to tell you that, you know, if we have a pressure vessel, you know, what's too much pressure? What's the effect of no pressure or a vacuum on the vessel? Would it collapse inward? And then what's the consequence of that? You may have pressure, temperature, level, flow, be all different guide words in there, and you have to figure out the deviations. So PHA, process hazard analysis, often done using Hazop. What cues are used when conducting the Hazop? The process instrumentation diagrams, the design failure effective mode analysis, Ishikawa diagrams, or guide words. Type in chat what you think it is. Very good. It's going to be D, guide words. And all these other things like failure effective mode analysis, Ishikawa, could be on the test. I find Ishikawa's up on the test quite a bit. Every other test has that. Failure effective mode analysis, probably every 5 tests. So it's out there. It's going to go over, and the idea is it's going to figure out what can happen and what's the consequence as far as seriousness of it, and they can actually quantify the frequency based on past data. But the idea is that you're going to try to eliminate these failures. So if you have process piping, corrosion is a common one. How often would corrosion cause the leak? You can actually quantify it based on your past history. And a lot of this is going to go over here. Select the wrong color seatbelt. I don't know why they're going to pick a seatbelt. And severity is 5 is middle, 10 is most severe. Probability of occurrence. This is building a product or a car. I mean, I would think, how many times have you seen a wrong seatbelt in a car? 0. I've never seen it in my life. So putting a 5 is probably a wrong number. You base it on data. You got a million products out there with a seatbelt on it. Probably not going to make that mistake. So right there, by quantifying it, you're giving a high probability of this issue to occur. Fault tree is a common one. A lot of when I started out, the aerospace industry used this quite a bit. They try to sit there and say, okay, we don't have a light in the room. What are all the possible causes? And they would diagram these on a flow chart like this. And the symbols, you don't have to go into, but the idea is that if we don't have voltage or we don't have the light bulb is in working condition, those are 2 failures that could cause, and then they analyze what could cause those 2 issues to happen. So a lot of people like it. It's very complicated, and if you're doing something very complex with a lot of different inputs, this might be an area you'd use this in. But for most people in safety, you would not use this. Again, you think about what the event that is not going to be desirable. The machine double trips or shocks somebody. You can actually figure out all the different inputs that would be a core, and what are the events that triggered this. Fishbone I see all the time. This is came from Japan by Mr. Ishikawa. It's evolved. Used to be there was only 4 things. Now people are adding 5, 6, 7, 8 things. You can put whatever node is, but the part is produced wrong side. The machine malfunctioned. Employee made a mistake. The machine is defective. You can list everything that's going. They do what they call brainstorming, and brainstorming is everybody thinks of things that could cause it to do it, and you just try to put them in these categories, and then you can flesh this out a little bit more detail. So it kind of looks like a skeleton of a fish. Okay, the most common used process hazard analysis tool is going to be the Hazop, hazard operability analysis study, job hazard analysis, systematic cause event tree, energy flow, and analytical procedure. This should be easy because there's only 2 of them that's going to be choice of. And the key word is in process safety management versus regular safety. And it is hazard operability study. So the key word in that one is process safety management. What if analysis, when they were working on the process safety management in the standard in the 90s, early 90s, this was an analysis they were considering. What if this happens? What if the relief valve lets go? What would happen? It's more question and answer. It's not very organized a lot of times. It's more for brainstorming. But what if the intake of the air filter goes? Well, these are the consequences. The compressor won't breathe. It'll maybe damage the shaft, and that's going to be an issue. And what could we do? Well, we're going to put a screen. One of the things they talk about is not a screen. A screen at the air intake. You got to have it in there. It's going to be a filter or kind of a box that's going to filter out the air, because you don't want particles in the air compressor. And then you're going to check, the pressure gauges and do periodic maintenance on it. This, like you can see, in a large process, could be very complex. You do not want 300 of these what-ifs. That's where you might do a Hazop, and every node is done differently and looked at it, because this makes it very tough, because if it's not in a logical flow, it becomes very hard to use, and so a lot of people do not use it very often. What is the key elements of the what-if analysis? Designed to support a root cause analysis, requires minimal time, has few resources, needs little preparation, fulfills the regulatory requirements for pre-task planning, cost-effective, uses a multi-skilled team, and is qualitative in its approach. That's a tough question. You're right. Very good. A. Very good. Now, one of the things that I want you to do is take each one of these things and put a little time and study them, because it's not going to, you just can't learn it this 1 second and come back. You're going to have to kind of go through it and read a little bit about the origin of each of these methods, because you will get, out of these 8 or 10 methods, you'll get 2 questions at least on them. Other ones that we see.
But John,
Yes, sir.
yeah, John, I have a question. Like in that one, why not the second option?
Now, the key one on this one is requires minimal time, few resources, need a little preparation. Well, it needs a lot of preparation, actually, because you have to think about every single thing that could go wrong. But the idea is that you're going to be able to figure out the root causes when we go back here. Let me back up here. What are the conditions that are root causes that could cause an issue? That's what it's kind of forcing you to make a root cause analysis when you do this. So that's the idea of that question.
Thank you.
Then the SCAD has come up about once out of every 4 tests now. Energy trace barrier analysis once out of 20. I mean, one person said they had a question on it. So these are other ones you might need to read up on. I honestly don't like the SCAD, because SCAD is just pull down menu. It lists everything that could go wrong, like 20 different things for methods, 20 different things for environment, and you just kind of click on it. A lot of people like it because it's faster, because you don't have to think of all these different things. They kind of just pull down menu, but the trouble is you just get used to doing that menu choice, and that's not, to me, very good. Management of change. There's been you're always going to get 1, 2, or 3 questions on management of change. The record has been 5, but the idea is that we want to go in and make a change. We're going to get a bigger compressor. What is the effect on the process? So we have to analyze the impact on it. Well, if you're going to start forcing air out at twice the speed and pressure, then the piping has to be evaluated, because maybe it can't handle that. Then the people are going to look at this. Is going to be a formal process. There's going to be people who are going to look at this. The process engineer is going to look at it. You're going to look at it. They're all going to approve or deny it, and then you implement the change, and then you follow up on the change. Make sure that it is what you thought it was going to be. I wrote the first process safety management change under the general duty clause at a company called Cargill, because they had an issue of the ammonia is getting pressurized too high and it's leaking. It's going past the piping seal design. So if the piping was at, let's say, 50 pounds per pressure, and you're pushing the ammonia at 125, you're going to cause some of these gaskets and seals to break, and that was causing the leak. And I says, you evaluate it because you want more cooling, but you created a problem. You didn't update the piping. So that's another example of it. But it could be. Go ahead.
I just wanted to kind of ask a special comment. In construction, of course, we're not dealing with PSM, but I know MOC is starting to become more widely utilized, especially with SIMOPS issues and scheduling issues, equipment changes.
Yep.
So is there anything in MOC regulation about construction utilizing that for those purposes?
No, they'd have to go indirectly under the accident prevention program, since it's a program. Okay. And that's where, construction, if you're not into the process safety side, then it's going to be an issue. That gets into also what they call trade stacking, where you start to have scheduling so tight, you actually make a change in the schedule. Are you putting 2 different trades right on top of each other for that same area of the construction site?
Right. Is somebody introducing hazards to somebody else? It's a go, no-go kind of situation. So, okay, thank you. It's become a very controversial issue, should I say? Well, I've always done this, and it's always been controversial, but I'm starting to see some of the larger GCs implementing this.
Right. I mean, everything's going by software, and the days of rainouts and mud are not really considered, and that messes up schedules, and all of a sudden, you know, you're 3 days behind, and you know, now you have to say, do we work people on a Saturday and pay them more time because it's not going to be the same rate? So these all become an issue, you know, when everything is supposed to be perfect. It doesn't work that way with weather.
Thank you.
All right. How can effective management of potential risks at the task level be accomplished? Now, this is kind of like a different style of question, but it's under this, you know, the category. Keep workers out of the area, use the proper PPE, compiling, discussing safety analysis with the workers, hiring workers certified in performing the task. So we're managing the effective management of the risk. That's a different style of topic. You could call that safety management, but they called it risk management in one of the tests I took. What do you think? Very good. One of the things you're going to notice, a lot of the answers is always talk to the workers, employee engagement. That is always going to be a choice that you're going to have. You're probably going to be right in that one. You know, anything that's going to make the process better has worker involvement is what they're always going to try to push. Any questions? Okay, and we're right on time for 30 minutes. All right, well, thank you.